look at solving basic trig equations within an interval. Okay, so solve the following for theta in the interval 0 degrees, where theta is between 0 degrees and 360 degrees, giving your answer to 1 decimal place. So our first question is cos theta equals 0.4. So make sure we've got our calculator in degrees. So we want to find theta first. So theta equals cos inverse of 0.4. So we can use our calculator. Cos inverse of 0.4 is 66.421825152. I'm not rounding yet because I'm going to give my answer to 1 decimal place instead. This isn't my answer yet. I will list all my answers at the end. So I'm going to show you how to do this with a cos graph and with a cast diagram. So because I'm working with cos, I'm going to draw the cos graph because it's between 0 and 360, and this is between 0 and 360. That's how I'm going to draw it. 90, 180, 270, 360. You can add them on if you want to, but I just want to do a quick sketch. So my cos graph will look like this, and 66 is roughly about here. Okay, so I know that there will be another value which is over here that I would like to find. This is the other value that I need to find. Okay, so we can see that this value here was 360. This distance with a wiggly line is the same as this distance with a wiggly line. So if that's 66.421825152, that's going to be as well. So I can work out theta, another value for theta, by doing 360 take away 66.421825152, which is 293.578178.5. So I know that I've got both solutions. I can see that within this range, 0 to 360, I've got that solution, it's 66, and I've got that solution, which is 293. So now I can list my values for theta. So theta equals 1 decimal place, 66.4 degrees, comma, 293.6 degrees. Okay, that's with the drawing of the cos graph. Okay, if you want to use a cast diagram, so we had the values, I'll try and show you them both. So we had the value, before we found 293, we had 66, roughly. So 66 on our cast diagram would be obviously higher than 0 degrees, but less than 90 degrees. So it would be about here. That would be about 66 degrees. Okay, so we are working with cos, working with cosine. So over here, cos is negative, but we've currently got a positive solution. So if we went over here, we'd be finding the negative solution, but that's not the same. Here, we want the same solutions, okay, the same value. So the only other place that cos is going to remain positive is down here. So down here, that's how to find the other solution. So this angle is also going to be 66 degrees. You could end up kind of going all the way around, okay, but obviously we can work out this kind of value of all this way around here by doing 360 take away the 66, which is exactly what we've done up here. 360 take away our 66 value. Okay, so the next one, B, we've got sine theta equals 0.27. So if we want to find theta, we've got sine inverse of 0.27. So theta equals sine inverse of 0.27. 15, I'm not going to round yet, it's not the end, 0.664266685. Okay, because I'm working with sine, I'm just going to quickly sketch the sine graph between my values. So it's asked me between 0 and 360. Okay, so we can see it's just a quick sketch, doesn't need to be anything fancy, just so you can see. So 15 degrees is roughly about here. Okay, we want to find any other values that are the same, so we go along and we can see that that value there is going to be the same. Okay, this distance is the same as this distance, so to find the other theta, we're going to do 180 take away our 15.66426685. So that means that theta is equal to 180, 164.3357331. So then we obviously one decimal place, so theta equals 15.7, round it, and 164.3. On the cast diagram, so we had the original value of 15.66426685. So if I was to draw that angle on here, then it would be about there. So that would be about 15, roughly. Okay. The only other place that is going to be the same, if all are positive here, the only other place we've got sine is positive, which will give us the same value, is over here. So we want this angle to be 15 degrees roughly as well in there. So the way we can work that out is we want to work out this size of the whole angle up to there. Well, we can just do 180, because if that's 0, that's 180. 180 take away our 15 to get this value here for our other value for sine. Okay, remember, if you're going that way around clockwise, it's negative. Okay, whereas if you're going anti-clockwise, then it's positive. So we're doing 180 take away the 15 to get to our other value. Okay, which we've done earlier on, which gives us 164.3. So the next one is tan. So we've got tan theta equals 1.6. So we know that theta equals tan inverse of 1.6. So theta equals tan inverse of 1.6, 57.9946169. Because I've got tan, I'm going to draw a quick sketch of the tan graph between the values that I've been asked to find. I know that there's an asymptote at 90 and at 270. So there's my tan graph. This value is 57, which is roughly about here. So I can see that there's another value on the graph there, which will give us this value here. So I want to find that other solution there. So we can see if that's 180, that distance there is the same as the distance from 180 to that point. So I need to do 180, add on my value. So we've got theta equals 180 plus our 57.99461679. So theta, so we've got 180 plus our answer, 237.994616. This is 8. Okay. You could call them theta 1 and theta 2. There are two values for theta, but theta is equal to 58.0 when we round and 238.0 when we round. Okay, so have a go at these three questions within the interval 0 to 360. So I want all solutions between 0 and 360. So you've got cos theta equals 0.185. You've got sine theta equals negative 0.6. Go careful with that one, it's got a negative. And C is tan theta equals 3.4. So I would pause the video and have a go at those. I'm going to go through them quite quickly. You should use these as you're checking your answers, but you need to be having a go at them on your own. So cos theta, so that means theta is cos inverse of 0.185. So theta equals our cos inverse of 0.185 is 79.3388676. If I draw cos quickly, 90, 180 to 7360, I can see here's one solution, there's the other, so I've got to do 360, sorry, take away the value. So theta equals 360, take away my 79.3388676. So theta also equals 360, take away our answer, 280.661132. So one decimal place, theta equals 79.3 and 280.7. Okay, next one, sine theta equals negative 0.6 this time. So theta equals sine inverse of negative 0.6. So sine theta negative 0.6 is minus 36.86989765. Even though my solutions are between 0 and 360, I'm going to draw it between negative 90 and 360 because my solution is less than 0. So it's going to help me. So we're working with sine. So here I've got negative 36.8, which is about here. So that's my solution there. That's the one we've been given. But I can see within my range, there's that solution there and that solution there. So to find theta, I'm going to need to do 180 take negative 36.8698 blah blah blah, and I'm going to need to do 360 add negative 36, which will eventually give us this value and this value. So I'm doing 180, it'll end up being plus 36.86989765, which equals 216.86989766, and our other value 360 take 36.86989765 323.13011024. So theta equals, doesn't want this value because that's not between our range. So theta equals 216.9 or 323.1. Okay, and the last one, same process at the start. So theta equals tan inverse of 3.4. So theta equals shift tan of 3.4 is 73.61045967. Okay, going to draw my tan graph. Asymptote at 90, asymptote at 270. So 73 is about here. I can see I've got another value there. So the other value is going to be, that's 180. So 180 add on 73. So that's our other value. So theta also equals 180, add on our value, 253.6104597. So I can say that theta is equal to 73.6 and 253.6 as well.